When was the last time you really looked at something like a pair of scissors? Or maybe a toolbox? They seem so simple, right? But it turns out hidden inside them is this incredible engineering principle. It's pretty much in everything that moves. And today, we're going to pull back the curtain and see what's going on. So let's just jump right in with a little puzzle. What on earth could a simple pair of scissors have in common with one of those big, multi-layered folding toolboxes? I mean, they seem like they're from different planets, don't they? One's for a single, straightforward cut, and the other is this complex storage system. At first glance, yeah, these two things couldn't be more different. You've got the super simple, direct action of the scissors, and then the complex, sort of beautiful, unfolding motion of this toolbox. But here's the amazing part. They are both built on the exact same mechanical idea, and by the end of this, you're going to see exactly how. All right, so to crack this puzzle, we've got to go back to square one. We need to find this single, fundamental building block that both of these tools are made of. And that building block is something called the paired lever. Okay, first things first, there's a word we need to get our heads around. The source material calls this a linkage, and really, that's just a fancy way of saying you've got two or more levers that are joined together. It sounds incredibly simple, I know, but trust me, this is the starting point for literally everything we're about to see. And we can get even a little more specific here. A paired lever is our first step up the ladder. It's not just any two levers stuck together, but two levers that are specifically joined so they can work together as a team. This simple, elegant concept is at the heart of so many tools. And this, right here, is the magic of it all. These simple mechanical pairs are kind of the unsung heroes of our everyday lives. They're the little engine behind countless tools that we just pick up and use without ever stopping to think about the clever physics making it all happen. Okay, but here's where it gets really interesting. It turns out not all paired levers are created equal. Nope. Depending on how you arrange them, they actually fall into three different classes, and each one gives us a totally unique mechanical advantage. So let's kick things off with first-class levers. The scissor is the classic example here. The key thing to notice is that the pivot, the little screw in the middle, is located between where you put in the effort with your hand and where the work gets done at the blades. This setup makes them super versatile for cutting, pinching, you name it. Next up, we've got second-class levers. Now, these guys are the heavy lifters, the real powerhouses of the group. Their whole design is about multiplying your force. So you put in a big, easy movement, and what you get out is a really strong, focused force. It's absolutely perfect for tough jobs, like cracking a stubborn nut or punching a hole in something. And finally, we have third-class levers. And this is where we see a fascinating trade-off. See, unlike the powerhouses we just talked about, these levers actually make things harder, force-wise. But what you lose in power, you gain in something else: precision and control. Think about tweezers or tongs. You're sacrificing raw strength for the ability to make these tiny, incredibly accurate movements. So let's just quickly put that all together. First class gives you that all-around versatility for cutting. Second class brings the raw power for crushing. And third class gives you that delicate, fine-tuned precision for grabbing. And the amazing thing is, the only real difference between them is just where you put the pivot, the effort, and the load. All right, so we've got the basics down, right? Simple pairs. But what happens when we start, chaining them together? That's when we go from a single fixed pivot point to a whole system of moving parts. And believe me, that's when things get really cool. This quote from the source material just hits the nail on the head. In a simple lever, that pivot is stuck in one place. But in a complex linkage, you suddenly have pivots that move around, in addition to the fixed one. This, right here, is the game changer that unlocks a whole new world of motion. And you can see this leap in complexity perfectly in these diagrams. On the left, you've just got a simple lever, swinging around one fixed point. Boring. But look at the one on the right. By adding more levers, we create these new pivots that actually travel through space as the whole thing moves. This is what allows for really sophisticated, complex movement. So when we say complex linkage, all we're really talking about is a team of those simple levers we've already met. But when you put them all together, they create these amazing systems that can fold, expand, and move in all sorts of incredibly useful ways. Okay, so now we get it. We know what a complex linkage is. So let's go back to our original puzzle and see this awesome principle in action. I promise, once you see it here, you are going to start seeing it everywhere. Remember our toolbacks, those metal arms connecting all the trays? That is a beautiful example of a complex linkage. As you pull that handle up, the whole system of levers and moving pivots works together to make sure all the trays spread out perfectly, so you can see everything at once. It's so simple, but it's absolutely brilliant. And here's another fantastic example, a folding stepladder. When you open it up, the linkages stretch out and lock into this super strong, stable triangular shape. But when you're done with it, that exact same linkage system allows the whole thing to fold down into a nice, compact, flat shape that you can slide into a closet. Strength when you need it, and convenience when you don't, all thanks to a few cleverly arranged levers. So there you have it. That's the secret. The hidden connection between the simplest pair of scissors and the most complex toolbox. It's all about linkages. A pair of scissors is just the basic unit, one paired lever. And the toolbox, well, that's just a whole collection of those same units, all linked together to create this elaborate, elegant, and incredibly useful motion. So, I'm going to leave you with a little challenge. Now that you're in on the secret, from the simple pairs to the complex chains, where else can you spot them? Take a look around you. An adjustable desk lamp, maybe the suspension on a car, even an umbrella. You're going to find that the world is just full of this hidden mechanical language, and now you know how to read it.